Hello and welcome to our lesson on multiplication of polynomials. This is going to be from section 4.2 in our text. In this lesson, we're going to start with the most basic multiplication I can think of, which is a monomial times a monomial, and then we will gradually step it up until we climax at a trinomial times a trinomial. Let's get started. Our first example here is going to be number 3. Here we have a monomial times a monomial. Here, this is one term, and this is one term. And there's two things you need to do when you're multiplying terms together. Step number 1, you're going to multiply their coefficients. So 2 times negative 10 is negative 20. And then you're going to multiply the variables. And if the letters are the same, add their powers. So here we have x to the 1 times x to the 2. If the letters are the same, add their powers. That'll make x to the 3. And then notice I have this other variable y, which there's no other y to multiply by. So that y is going to come down, and that's our answer. Next, number 7, we're going to step it up a notch this time. Here we have a monomial times a binomial. And this is going to be the distributive property. The 2z is going to distribute to everybody in the parentheses. So first we're going to say 2z times 7, which is 14z. And then notice when I multiply the 2z times negative z, here I'm going to reiterate the two steps that I mentioned in problem number 3. Okay, step number 1, you need to multiply the coefficients. 2 times negative 1 is negative 2. And then if the letters are the same, add their powers. Z to the 1 times z to the 1 makes z squared. And that is done. That is a monomial times a binomial. And the next example, the textbook did not have what I wanted to do next, so I had to make it up. This is my problem. Here, the next logical step up would be a monomial times a trinomial. So the 2x squared is a monomial. Inside the parentheses, we have 1, 2, 3 terms. That's a trinomial. But again, this is just the distributive property. So we're going to distribute 2x squared times x squared, multiply the coefficients. If the letters are the same, add their powers. Next, 2x squared times negative 3x. 2 times negative 3 is negative 6. X to the 1 plus 2 is 3. And last but not least, 2x squared times the constant. 2 times 4 makes 8. The 4 does not have an x, so the x squared comes along for the ride, and that is done. All right, so at this point, the first 3 examples are monomial multiplication, a monomial times a monomial times a binomial, and a monomial times a trinomial. We could keep cranking that up, but it's simply going to be the distributive property. So the next logical increment would be to step it up to number 13 here. This is a binomial times a binomial. So what I need you to know, when you have a binomial times a binomial, that is the 4-letter F word in math. Okay, that is the FOIL method. So this is where we get to say, let's F it up. We're going to FOIL it. And this, again, at this point, I'm going to tell you that any polynomial multiplication can be simplified down to just the distributive property. So if you understand the distributive property, you can do any polynomial multiplication. So what we're going to do first is we're going to distribute the 5x to both of the terms in the second set of parentheses. So multiplying first, 5x times 3x. Remember I said that you multiply the coefficients, and if the letters are the same, add their powers. So that's going to give us an x squared. And notice that those are the first two that we do. Next, we're going to multiply the 5x times the negative 1. Again, multiply the coefficients. Negative 1 times 5 is negative 5. And this x is the only x there is. The 1 doesn't have an x, so that x comes down. And then if you notice, those two that we just did are on the outside. So we did the first and then the outside. And now notice that the 5x has been, let's say, used up. He has been distributed to both terms in the second set of parentheses. So now it's the 2's turn to distribute. So we're going to do 2 times 3x. Multiply the coefficients. 2 times 3 is 6. And then the 3 is the only x that exists, so the x comes down. And notice that those two terms are on the inside. Those are the inner terms. And then the 2 gets to distribute to the negative 1. And those are the last ones we do. So now maybe you can see that FOIL is basically the distributive property. You do the first two, and then on the outside, then the two terms on the inside, and then the 2 and the negative 1 are the last ones you do. 2 times negative 1 is negative 2. And to finish this problem up, you always need to CLT if possible. And remember, CLT stands for combine like terms. So we're going to have 15x squared plus x minus 2 as our final answer. Next, logical increment would be a binomial times a trinomial. So here we have a binomial times a trinomial. Again, I would like to emphasize that this is going to be just the distributive property. The x is going to distribute first to all three terms in the second set of parentheses. All right, so here we go. Let's break it down. Remember I said multiply the coefficients. 1 times 1 is 1. If the letters are the same, add their powers. 1 plus 2 is 3. So our very first term is going to be x cubed. And then we're going to multiply the x times the 4x. So again, multiply the coefficients. 4 times 1 is 4. If the letters are the same, add their powers. 1 plus 1 is 2. Gives me an x squared. Next, we're going to multiply the x times the 16. 16 times x is just 16x. And now that we've used up the x, it's time to distribute the negative 4. So negative 4 times x squared is going to give us negative 4x squared. And I'm going to use a technique that I call the stacking technique. So when I do the distributive property with the negative 4, instead of continuing to write it out here to the side, I'm going to use the stacking technique. I'm going to line up my like terms as I go. So negative 4 times x squared is negative 4x squared. Negative 4 times 4x is going to be negative 16x. Again, using the stacking technique to line up my like terms. Last but not least, we have negative 4 times 16, which is negative 64. And since there is no constant on this first row, the negative 64 just kind of hangs off the end. And then to finish it up, remember I said you need to combine like terms. This is where the stacking technique is helpful because it already has your like terms lined up. So we can see the x cubed comes down and the x squareds cancel and the x's cancel. So the only term left is the minus 64, and that is our final answer for that problem. And for the culmination of the polynomial multiplication, here we have a trinomial times a trinomial. Any polynomial multiplication can be explained as the distributive property. So the a squared is going to distribute to every term in the second set of parentheses. Here we go. A squared times a squared. If the letters are the same, add their powers. That's going to make a to the fourth. A squared times 4a. 4 times 1 is 4. A to the 2 and a to the 1 is a to the 3. That's 4a cubed. And a squared times negative 5, that is negative 5a squared. And that's going to do it for the a squared. Next, the a is going to distribute to all three terms. And again, I'm going to demonstrate the stacking technique. So first, we have a times a squared, which is going to give me a to the third, stacking my like terms. A times 4a, 1 and 1 is 2. That's going to be 4a squared. And a times negative 5 is a negative 5a. And that does it for the a term. And last but not least, we're going to distribute the negative 1 to every term in the second set of parentheses. So here we go. Negative 1 times a squared, that is negative a squared, using my stacking technique. Negative 1 times 4a, negative 4a. And last but not least, negative 1 times negative 5 is a positive 5. I love the stacking technique because it makes it super easy to combine like terms to finish it. A to the fourth comes down, and then for the a cubed, 4 plus 1, that is a positive 5a cubed. And then look at my a terms. Negative 5 plus 4 is negative 1. And a negative 1, that's negative 2a squared minus 9a plus 5. And that's done. And not only is it simplified completely, notice it's also in descending order, which is nice. That's using our good math etiquette. And the last example we're going to look at in this lesson, number 43. On the surface, you may not see that as polynomial multiplication, but you need to understand what it means to square something. Remember, to square anything means to multiply by itself. So here we're going to have a binomial, x minus 2y times itself. And now we can see that that is a binomial times a binomial. Remember, that's the four-letter F word in math. So we can say curses, foiled again. We're going to have to foil this again. So I did want to show this to let you know that sometimes you have polynomial multiplication even though it doesn't really look like it. And so you need to be able to recognize that. So we're going to practice the FOIL method one more time. Here we go. First, x times x gives me x squared. On the outside, remember the steps are multiply the coefficients. Negative 2 times 1 is negative 2. And if the letters are the same, add their powers. But x and y, those are not the same letter. So you may be wondering, should I put xy or yx? Does it really matter? Well, technically no, but sort of yes, okay? It does sort of matter because we want to use good math etiquette. And good math etiquette says if you have more than one variable in a term, they need to be in alphabetical order. So it's not wrong to say negative 2yx. It's not wrong. It's just not right. Okay, that's okay, but this is better. Next, on the inside, again, I've got a negative 2xy. And last but not least, negative 2 times negative 2 is positive 4. Oh, and the letters are the same, add their powers. And don't forget to CLT, don't forget to combine like terms to finish it off. I've got a negative 2xy and a negative 2xy. That makes a negative 4 of those. Negative 4xy plus 4y squared, and that is done. That is simplified completely. And that's it for this lesson. So if you have any questions or comments about anything I've done, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.